right, so this is walking through how to complete the lab 2 spectroscopy data. So from the lab with table 1, it just wanted you to look at volumes and concentrations for each step of the solution. So this was just your dilutions. So for 0, it was 0.1 liters. For 1, it was 0.2, 0.4, 0.8, and 1. Okay, and so then the concentration was just a readout that you hovered over. So this one should have started at 5.5 because it wasn't diluted. And then these would have gone down just so you could see that as you did each dilution, the concentration went down. The next was making your standard curve. So the first step was using the equation that they gave us in the lab on how to go from millimolar to parts per million. So this was the number given in that calculation from 25 millimolar to 22.4 times 10 to the third parts per million. And so instead, I'm going to actually make an equation in Google Sheets. So anytime you're doing this, you start with equals. So the way that this was set up in the lab was it was the concentration in millimolar times 1,000, and that gives me molar. And the next step, I did times 898. That's the molar mass of the red food dye. So now instead of being in moles per liter, which is molar, it's moles per liter, at this step I have done grams per liter. And so parts per million is just milligrams per liter. So in order to get it back to milligrams, I'm going to divide 5,000. And it gives me 22,450. Okay. And so now what I can do is drag this down, and it automatically changes where instead of saying 25, it does it for A12, which is 50, and so on and so forth. Okay. The absorbance at lambda max was something that you would have measured in the lab. So this is data that you're just copying down from the screen as you put these concentrations in. So these are just some samples, so yours are probably different. Remember, you're just entering them. And so our next step is to create our calibration curve. So I'm going to go ahead and just select all of my data, all of these numbers right here. Go to Insert, Chart. Okay, pull it over here. So whenever it pops up, hopefully it says Scatter Chart. That's good. That's what you want. Your x-axis, it says A10 through 14, which is the concentration in millimolar. That's awesome. That's what you want. So when it says series, it's talking about the different things that you're plotting versus the y-axis. So I actually don't need this against concentration again, right? So I'm going to go ahead and remove that series. So now I just have concentration versus absorbance. So I'm going to go to Customize, Chart Axis and Titles. My chart title, I'm going to say Calibration Curve for red food dye. Okay. And then I'm going to do my vertical axis title because my horizontal is already done down here. My vertical axis is absorbance. Okay. And absorbance, remember, doesn't have units. So it's just absorbance. Series. So you're looking at data series 1, which is the only one there is. You want to scroll down and click trend line. And so what that does is it just does a line of best fit. So you'll notice it's not perfectly connecting the dots. It's just it's like they laid a ruler down and said, this line best fits my data. And you want to go to label. So after you've done trend line, this all pops up. Use equation, and it'll put the equation right here at the top. Okay, and remember, your equation may look a little bit different from mine just because your absorbances may be different. That's fine. Okay, so now that I have this, I'm going to come down and we're going to do part 3 where you're looking at the 3 unknowns. And so these could be things like red Gatorade, Kool-Aid, things like that would have this red food dye. And you're trying to figure out the concentration of red food dye in these things. So you're looking at the absorbance at the same wavelength. And with this, they gave you the absorbances. Okay, so it was 0.62, 0.27, and 0.91. All right, so with the concentration, we're going to calculate this using this relationship that we have just found, right? Because we've done a relationship between absorbance and concentration. So beforehand, we had the concentration, we found absorbance, and now we have absorbance. We're going to use it to back find concentration. So if I know that this is equal to absorbance, the blue dot, so absorbance equals this slope times concentration, I'm going to rearrange this equation to essentially be concentration equals absorbance divided by the slope. Okay, so concentration equals the absorbance divided by the slope. And so I'm going to take it out of scientific notation, right? So 5.08 times 10 to the negative third. You just move the decimal 3 times to the left. 1, 2, 3. So it's 0.00508. And that gives you your concentration in millimolar. And we know it's in millimolar because that's what our graph tells us. So I just dragged it down. And so now I'm going to go back to parts per million. So I'm essentially going to do the same thing I did here. So equals this concentration. So up here I did times 1,000. And then later I did divided by 1,000, which you could still do. But since I'm multiplying and dividing by the same number, they cancel out. So I'm just going to skip that step and do times 898. And there's my concentration in parts per million. All right, and that's how I get all of the data from my data table. So let me know if you have questions moving forward.